So glycolysis only extracted about 12% of the fuel in glucose. We still have a lot of fuel left in the byproduct, which is pyruvate. Pyruvate is going to be fed into the mitochondrion if oxygen is present. So if oxygen is present, so we'll just sort of give like a fork in the road. So O2, yes, it gets fed into the mitochondrion. If O2 is not present, then this pyruvate will actually stay in the cytoplasm so that it can be used in a process called fermentation. Fermentation is a process that does not generate any ATP, but it's important because it allows glycolysis to continue. We'll get into the mechanisms of fermentation after we get done focusing on what happens to pyruvate if oxygen is present. So if oxygen is present, pyruvate is going to cross the mitochondrial outer membrane, and it's going to cross the mitochondrial inner membrane. Remember, the mitochondrion has a phospholipid bilayer that makes up the outer membrane. It has a phospholipid bilayer that makes up the inner membrane, so it's a double membrane organelle. And the mitochondrion itself has sort of like its own cytoplasm. It has its own cytoplasm. We call this the mitochondrial matrix. And then this space in between, this is a very important space that we'll talk more about in just a second. We call this the intermembrane space. The intermembrane space. So this pyruvate is going to cross the outer membrane. It's going to cross the inner membrane thanks to the help of transport proteins. Remember, this is a large polar molecule. It needs to cross these phospholipid bilayers. So we've got some transport proteins facilitating this process. And I'm just going to draw one pyruvate at a time to try to keep this as simple as possible. But just keep in mind that we've actually got two pyruvates coming in. When pyruvate comes in, it's going to be oxidized again by another NAD+. So there's an NAD+ in here waiting for it to come in. Again, I think of it as like a bucket, an empty bucket. It's going to swoop in and oxidize pyruvate. And just like before, it's going to steal some hydrogen. But what it's really going after are those high energy electrons, right? Buzz, buzz. And in the process of this happening, in the process of pyruvate being oxidized by NAD+ in the mitochondrial matrix, a carbon dioxide is going to be removed. A CO2 atom, CO2s, are going to be removed from pyruvate, and they're going to leave in the form of carbon dioxide. So you've got a carbon and two oxygens coming off of pyruvate. That's going to exit as a waste product. It will dissolve in your blood. You will eventually breathe it out. This is the carbon dioxide waste that you're breathing out right now. Okay, so we'll erase this for now, but keep in mind that this guy's still here. I just need to make room. What we're left with is a 2-carbon molecule that is going to be attached to an enzyme called coenzyme A. Coenzyme A. It's a coenzyme, right? So it's a small, non-peptide organic molecule that's associated with a protein. And coenzyme's job is to basically taxi the 2-carbon molecule and feed it into a cycle. So think of CoA as like an Uber or a Lyft. It's going to shuttle the 2-carbon molecule into this cycle called the citric acid cycle or the Krebs cycle, either one. And it's going to be this cycle where the remaining high energy electrons in this 2-carbon molecule are going to be stripped off of the molecule. And so that's what we'll talk about in the next video.